Welcome back. So now we are going to get to this practical thing. I want to talk to you about the ecosystem around SQL. So far in the lecture, we've looked at theory of the relational model, the relational algebra, the normal forms, Boy's code normal form, functional dependencies, and so on. We also looked at SQL as a language. So now you know how you can type SQL in the notebook and have fun writing queries, and you can project, select, group, aggregate, sort, filter with having, limit, offset, and so on. You can even nest queries into queries. So now you are reaching a level of mastery of SQL, right? And there will be SQL at the exam. So train on the Jupyter notebooks. You will have Jupyter notebooks with PostgreSQL on exam day. We'll tell you in advance the data set and so on, so you don't have to worry too much about it. I think the TA team also prepared some Docker that has all the data sets of previous years, so you can train extensively. But so far, this is SQL isolated from the rest. You just sit in front of your notebook and type SQL. But in reality, you just, I mean, some people do that, right? Data analysts, they might actually go and type SQL to analyze the data. But very often, that's not how it happens in reality. So we have a database that is installed on a machine, PostgreSQL, MySQL, and so on, and the users can insert and query data on the machine. But typically, it's part of a bigger picture and a bigger landscape with typically a full-fledged website and so on and so on, right? So we have data analysts that might directly query the database and trigger updates. Typically, in some companies, you also have people that still enter data and modify data in the database, but they don't know the first thing about SQL. Typically, what they do have is a desktop application that they open that connects to the database, but all they see is forms with text boxes and buttons that they click on. For example, in call centers, when you query the customer data and so on, you enter the customer ID and so on, then you see the info, you might modify it, click OK, that's confirmed. But you didn't write any SQL for that. That all worked directly with an interface that connects to the database. Who knows Microsoft Access? That is also one particular piece of software that does that sort of thing. So it's basically a way to have masks in front of the database, and you have people that are often called data clerks who manipulates the data in the database with these interfaces. Okay. But typically, what happens is that you might have more databases, more servers, and so on. So typically in a data center, so this is what I showed you right here, that in the data center, you have that sort of things. So if you think of Amazon, Azure, Google Cloud, and so on, you have this. In fact, you have them in Zurich. You have plenty of them. A few years ago, we went to a field trip actually with the class to a data center. It took us half an hour to enter the premises because of the security checks. And we saw the rooms filled with these things. So we have all of these servers sitting there that basically deliver the websites that you visit probably every day with your smartphones or your laptops. So in this more complex architecture, we have plenty of employees. So some coordinate, monitor, take care of access control, and so on. Some people structure the contents, you know, the schema and so on. They know their database design theory. They know their normal forms. So they are going to make sure that this is all respected. And then we have the power users. That's basically what today we know as full stack developers, which is quite a common title that people use on LinkedIn, for example. So they program on the three-tier stack. So this is here the three-tier architecture. I'm pretty sure some of you already kind of knew it or knew how that works, these three layers. I'm going to go in details about that, but basically you have the database servers that would be PostgreSQL. Then you have the application servers that's like PHP, Java EE, and so on, that sort of things. Maybe JavaScript. I know that some people like JavaScript on the server side. Then we have the web servers. This is what delivers the HTML pages and the pictures and so on, maybe executing, connecting to the application servers. Then we have the clients. That's your browser. Chrome, Safari, Firefox, Brave, whatever, that is on your laptop, and it might also execute code that's typically JavaScript on your actual laptop. Okay, so this is the three-tier stack. Now, if you go in more details, let's start with the web servers. This is what you connect to when your browser actually wants to connect to a website. You type www.ethz.ch or something in the address bar. and you're connecting to a web server. So let's do that. So we have here, it's somebody connecting to Amazon.com. What this does is that it sends an HTTP request. HTTP you all heard of because it's in the address bar, right? You know that that's the first thing that appears, HTTP://. By the way, Tim Berners-Lee, the inventor of the web, said that he regrets it, having the : / and so on, because that's a bit of a waste of space. And he said, I think a few times, that if he had to do it again, he probably would have downsized this site right there. But anyway, that's what you put in the address. And the HTTP that you see on the left stands for, yes, the microphone maybe. Yep. Hypertext. Does anybody know the TP? Hypertext? Transfer protocol, exactly. Hypertext transfer protocol. This is what was invented in 1989 at CERN, right here in Switzerland, in Geneva. So this is a request that gets shipped over TCP over IP, so the internet protocol, to another server. Now this is the one you have in the data center. And what happens is that that server is going to reply with HTML pages, with images, with videos, with streams, with additional data and so on. And that gets sent back to the user. And that's going to appear in the browser, right? So this is what happens. Typically here, there's going to be HTML, which is hypertext markup language, exactly, hypertext markup language. So these are the, if you actually, I don't know if you already did it, but you can look at the source code of an HTML page by clicking on the menu somewhere, view source code, and you will see these angle brackets everywhere. This is HTML. Then you have the images like JPEG, PNG, and so on that are displayed on the page and additional data. CSS is cascading style sheets. If I correctly remember, this is what makes the pages beautiful. If you don't have CSS, the page is going to be ugly, and you add CSS and then it looks beautiful, right? Some people are really good at these things. I'm not. I really don't know the first thing about how to make web pages look beautiful. It's a job in itself. And JavaScript is what animates the page. It's all the code that executes dynamically. Like if you imagine you connect to Google Maps, for example, if you scroll and so on, then some things get loaded and so on. This is JavaScript that's communicating with the server in real time. Okay, and you see this little arrow that is on the top right over there. Here, that's the communication with other tiers, because of course, in order to generate the HTML and the CSS, it needs to come from somewhere, right? You need to actually have some data in there. So typically, in order to generate this HTML, CSS, JavaScript, you have some fancy technologies. Apache Tomcat is a simple way of doing that. There's also Java EE, that is the enterprise edition of Java that allows you to do these big websites. There's also PHP. I'm sure, who knows PHP? Pretty sure some of you, right? Nobody knows PHP? Some of you, yeah, maybe it's getting out of fashion. You know, it might be that now there's cooler technologies than PHP, but PHP is also a language that people love to use to generate the pages dynamically. Okay, so these are the web servers. Now let's go to the application server. So these are other computers just like that. They're sitting on the same data center, but they do something else. So these application servers, they do fancy. It's called business logic, right, by the business people. So the business logic. So the web server tier, that was the one we discussed already, it has to generate the HTML pages with the contents and the CSS and images and so on. In order to know what to put on these pages, it has to request that information. So it connects to the application tier. And the application tier is going to generate some SQL query very often and sends the SQL query to the database tier, right? Then the data comes back from the database tier, and then there is plenty of complex and fancy code in Java or PHP or Node.js or whatever that processes the data in such a way that it generates this HTML, and then the HTML can be sent back, okay? So this is it needs a lot of programming. The people who do that, they are really good at programming, and they are the ones who dynamically generate the pages from the database. Now I need to talk about the last tier, the database tier. This is actually PostgreSQL. So these are one or multiple instances of there. So what happens is that in our case, I mean, it was pretty simple. In the case of the course, we just have one single database and schema and a few tables. In general, PostgreSQL views things like that. So you create a database. I think we call it ExamDB for the exam, or it might be called also Postgres by default. And then you can group the tables in what is called a schema. Now this is confusing. This is very confusing because the word schema here doesn't mean the same thing as the way I used it, right? So what I called the schema was the attributes and the domains and the constraints. But when you say schema in PostgreSQL, they mean something else. They really mean a group of tables within a database, right? So don't be confused by that. If you know that this word can be used in two ways, then you're good, right? Then you can have multiple databases in the same cluster, and you can have multiple clusters in the same environments. Okay, this is advanced, right? You don't really know. You don't need to know so much about that, right? But basically, if you start using databases and schemas, then when you have this select from where. Then in the from, you have the name of the table, but you can actually prefix the name of the table with a schema in a database. In the exercises, I think we don't do that because it's just the default schema, the default database, but you could, if you wanted to, specify a different schema in database. Again, that's the from clause in your SQL. So if you don't specify a database, it's the default one. If you don't specify a schema, it's the default one, and that's pretty much what you have in the exercises, just the table. And I think by default, if I'm correct, might depend on the operating system, the default database that it creates is just called Postgres, and the schema that it creates by default is just called public, right? And then you can go ahead and create others if you want to. Okay, so what's going to happen then is that the SQL client is connecting to the SQL server. Now, who's the SQL client here? The SQL client, if I come back here, the SQL client is my application tier. Right? This is the machine that generates SQL and connects to the database tier. So my client is the application tier. My server is the database tier. Okay, so I come back here now from the perspective of SQL. And what's going to happen is that the SQL client is opening a session with the SQL server, and it's just shipping SQL queries and getting back tables in return, right? It might be that the SQL client also has a few modules to interact with, you know, all the libraries and some codes that might be pre-stored and so on that it can interact with, right? But basically you have a session, you ship over SQL, you get back tables. So you see, it's just not a notebook in that case. It's not a Jupyter notebook. It's really just within Java or within PHP that this actually is done, right? Now, there are a few ways that this can happen. And it's a good idea to have a general understanding of all the ways that you can actually create SQL and connect to a database in practice. Some of them are advanced. You might never even have to deal with that. Maybe for you, for the most of you, Jupyter Notebooks is going to be enough if you just want to look at the data for a semester project or a master's thesis. But if you want to build a website, you might need to actually have SQL within a host language like Java or PHP. So for you, that might actually be useful. So I'm going to show you a little bit what it can look like. The first one is the easy one that you know. It's a SQL shell. So either a shell on the command line or Jupyter Notebooks. You input SQL, you get back your tables displayed on your screen. One query, one answer. The second way is typical for websites. You embed SQL in a host language, and there's several ways of doing that. And you generate a query in that way, in Java, in PHP. And then you have an application programming interface that's also called API that allows you to iterate over the table and process the results that you've just received. By the way, API is becoming a buzzword. I think with the venture capitalists and angel investors, like API, they kind of love that in the business world now. But for computer scientists, APIs have just been there forever, right? So API is just the interface you have when you connect with a system, like for example, PostgreSQL, but when you connect from it with Java or C++ or PHP. I will show you a few examples of that. The third one is more recent. It's also an API, but it's an API that is different, that is more meant for data analysts in order to manipulate tables or even data frames. Who heard of data frames? Some of you, pandas. Who heard of pandas? It's all over social media, all these influencers with Python and pandas and so on. So there are APIs like that. But it's questionable, and it's a matter of taste if you really want to use these APIs or if you prefer SQL, right? There are people who actually love pandas and prefer to use these data frame APIs. I think you should not underestimate the power of SQL for doing things much simpler than these APIs. Okay. Just a few words on data frames. You don't need to worry too much about that. Data frames, we'll cover it in Big Data for Engineers. Next spring, this is really an advanced generalization of tables that actually allows nestedness. You can have tables in tables. But in this course right now, we actually don't. So this is why we only have tables. Okay, now here's the problem. And this is why it's actually much, much more complicated than it actually seems. Because what's happening right here is that you want to query the database and you need to use SQL. That's the native language of the database. The problem is that the programming language that you use for your website, PHP, Java, and so on, it's completely different, right? SQL is a declarative language. You project, you select, you group by, you aggregate, and so on. It's highly optimized, returns the table. But in a language like Java or PHP, it's not like that. These languages are imperative. They look more like do this, do that, and then a for loop, and then a while loop, and if then else, and blah, 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 right? So I assume most of you know how to program a little bit, but basically these two worlds are completely different. They're completely different. And between the two is what we call an impedance mismatch. An impedance mismatch is like when the microphone does a lot of noise if you actually don't plug it the right way, right? So this is an impedance mismatch because I'm not an electronician, but the impedance or resistance might not fit between the loudspeaker and the microphone, right? That's pretty much all I know about these things, but I just know that it makes a lot of noise if you actually don't get the impedance right. So this is an impedance mismatch. And we also use that same word of impedance mismatch for databases that kind of doesn't fit together, the SQL side and the Java and PHP side. So there's a bit of glue in order to make it fit together and connect the two. And this is why we need these APIs. So one of the ways to do that is that in your language, Java or PHP, you are imperative. So you basically prepare statements, bind some parameters, execute the statement, that's going to be SQL, and process the results. So this is how you have these interfaces between these two worlds with the SQL world and the imperative programming language worlds. Now, this is what it looks like. Don't be scared. Don't be scared. I know this is very scary even for me. Oh my. So you see here what we have is basically SQL. I mean, you probably recognize something that looks like SQL right here, but it's kind of embedded in another language. In that case, it's C. So this is actually C and this is SQL. And in that case, it's basically people who kind of merged C and SQL. They basically defined kind of a new language where you have both SQL and C intertwined, right? So this is why you can have these code snippets right in the middle of a C program where you actually write your variables that you bind to SQL, and then you can use in SQL the query. And you see these little columns there, they are the connection with the language. You can basically create variables that you give names to, and then they will be replaced in the SQL query with the actual value that you have in your program, right? Who finds it scary? There's every reason to be scared. This is very complex. This is really the consequence of the impedance mismatch, right? We just have two different worlds, the SQL world and Java world. They are so different that we need glue. And this is pretty much the glue that people came up with, right? So these glues, C in that case, but it could be Java or PHP as well, to SQL. That's another example. So what is this one? I think it's Java. So here it was C. And here is Java. It's pretty much the same thing. So it's the idea that you have basically Java, and right in the middle of Java, you just have SQL glued like this. And again, that's very scary, but this is how you can basically have SQL in the middle of a Java language, right? So this is really advanced. You don't need to understand what this does, right? I'm really speaking on the high level. You are not required to actually understand what this does. All you need to understand is that there's this interface between Java or PHP or C on the one hand, and SQL on the other hand. There is a question on Zoom.
Does the syntax also depend on the type of SQL?
Yes, absolutely. You might have this complication as well, is that if you use PostgreSQL or you use MySQL and so on, that might even change. So yeah, it just makes it worse. Okay. So this is one way. Basically, you really have SQL literally in the language. There is a softer way that doesn't require merging languages or really embedding languages, is to just put the SQL query in a string, right? A SQL query is just a bunch of characters, right? That's what you type in Jupyter notebooks. So technically, you can take a SQL query and you add quotes here and quotes there, then you turn it into a string. And when you have a string, then a string is just what you have in Java, in PHP, all these languages have strings. So you just put your SQL query in a string, and then you pass that string to some function call that is part of your API connecting to PostgreSQL. So in that case, you basically say you previously created whatever you need to do, and you say execute query, that's part of the API to PostgreSQL, and there you just copy paste your SQL query that you want here, right? And then that's going to come back with the results of that query. So you see, in that case, it's not a Jupyter notebook. It's really something you do in a host language. Now you can imagine what you can do now, because here it's just a string, but you can actually build the strings dynamically in Java and PHP, right? In a programming language, you can build the strings in any way you want, right? So you can build your string, assemble a SQL query, and then ship it for execution. It's a bit easier than this. I think this is less scary, but I have a very, very, very big warning here. A very big warning, because that has actually a security implication. If you do things that way and you assemble your SQL strings in that way, potentially receiving input from a website, you basically open yourself to what is called a SQL injection attack. Because imagine that you build the string using something that was supplied by whoever connected to your website. You could have a malicious agent that starts writing stuff and then quotes, it basically ends the string, and then it goes ahead like drop table, blah, 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 blah. And then you can imagine the disaster for your database. So that's called a SQL injection attack. So this is why this is a bit risky. You have to be very careful if you use that sort of APIs. Do not blindly take over what you get from the people connecting to your website, because you could have very bad surprises if you do that, right? SQL injection attack is the term of that. All right, so the sort of things you do in a language, don't worry too much about the details, is that you basically have some connection string. It's called a connection string that contains the PostgreSQL. You have whatever server your PostgreSQL server is connected to, so that would be your laptop or the machine that you have, typically localhost if it's your laptop. And then here it's the name of the database that you connect to. This is called a connection string, right? This is just all the information to connect to say where you connect, to which PostgreSQL instance you connect. And somewhere you need to specify the user and you need to specify the password. Again, be careful, do not hard code the password in your programs. Typically, there's a bit some more fancy thing that stores the password somewhere else than hard code it. But technically, you pass it here, and then you connect to the using that string and user and password to PostgreSQL, and then you can go on and query using SQL, right? Another way to do that is to supply the user and password as part of the connection string, right? So you basically have the local host or the server, the database here, plus that's just assembling the string in Java. And then you have the user is ISC and the password is secret, right? It's just another way of you having your connection string. If I'm correct, these connection strings should be familiar to you because I think you do have them in the Jupyter notebooks, right? You do. At the start of the notebook, you specify the connection string, and basically the Jupyter notebook hides the rest from you. All of the rest is hidden. It's actually Python, but that's done in the background, so you don't need to worry about that. And whenever you type SQL in your Jupyter notebook, it's going to automatically make this call here with the query that you typed in the Jupyter notebook. Okay. Okay, so there are two ways to actually send your queries. One way is to create a statement, whatever that is, and then you call a SQL query with execute query. But there is another way that's actually, I will explain why, you can prepare a statement, but leaving some of the values open. For example, you could have parameters in your query that you don't specify just yet, you'll do it later, and then you execute the query at a later point in time, specifying the parameters. So the first way, the one on the left, looks like this. You create a statement, just calling create statement, and then you take the statement and say execute query, and then you paste your SQL string. Again, beware, SQL injection attacks and so on, very dangerous, be careful. But basically you put your SQL query in there and you get your results. The other way is the other way around. You prepare a statement passing the query right there, then it's in the statement already, and then when you execute, you don't need to specify the query anymore because you already specified it here. Why is that good? Because then you can re-execute the same queries plenty of times without repeating it. You already put it once and for all at this place, right? So these are really very similar, but really the difference here is you can repeat, right? Who is with me? Okay. So now the next question is, what do you do with that result set? Because you probably guess that this is where the table is that you get returned, right? But what do you do with that? How do you access that table? And here it is. You have your result set, that's just an object in Java or PHP or whatever language you have. And technically the table on the right is a virtual representation of what you're iterating on, but you don't see it yet. All you have is now your result set. So what you do is, it's called the Volcano iterator. You call next, you basically keep looking at the next tuple. So you call next, and next the first time is going to point to the first tuple in your table. Then what you can do is get string 1. What is happening here? 1 is the number of the column. So here you probably already see this imperfect thing that technically the order of the column matters in this API. Whether that's good or not, I leave you the judge of that. But in that case, in this API, you do have an order on the columns. So the first column is named, the second year and ID. So you say get string 1. So you have to know that this is a string from the schema. And that returns Einstein, right? You're pointing to that tuple. Get string of the first column, that's Einstein. Then you say get int 2, because you know it's an integer, you get 1909, right? Then you get int again, it's an integer from ID, then you get 1. For whom is that clear? Right. So this is how it happens. You call next, and then you get all the values you have in the columns. In the API, there are also ways to specify instead the name of the attribute, right? That's also another way of doing that. But many APIs let you specify the number of the column. Then we do next. What happens? We get to the second one. So again, get string 1 gives us the first value, Mirzakani. Then get int 2 gives us the year 2014. Get int 3, the ID 2, right? Then we call next again, and so on and so on and so on. Typically, what's going to happen is that this next is going to be in a while loop. A while loop, who knows what a while loop is? Some of you program, right? A while loop is just a way in a program to keep repeating until you run out of tuples, right? So this is just going to keep doing next, 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 next until you reach the end of the table, and then you're done. What's typically going to happen in there, because you might be wondering, what do I do with this, right? A very common use case is that you're going to generate an HTML page. Who knows in an HTML page, table, TR, TD? Never heard of that, HTML? These are basically tags in HTML. So TR is for the rows and TD is for every cell in your table. So basically what's going to happen is that you keep generating the HTML tags that are going to create your table in such a way that you actually can display this on the HTML page. You can actually make this appear on the page, but you have to use this PHP code in order to create the HTML tags that will render the page like this, right? Does it make sense? Right. I think you should understand, even if you don't know HTML, just get the idea of that, right? That HTML is a language that allows you to display things, to generate a page and a look and feel of a page. And you can programmatically generate the content of the page by iterating over what you get from PostgreSQL. And then you create the display of the table using the HTML tags in there. Okay. So let me check the time. Getting close? Yeah, still have a bit of time. Okay. Okay, you can also do updates using that. This is why it can become dangerous now. You can also say insert into blah, blah, blah with execute update instead of execute query. So that's also the sort of things you can do. This is even more dangerous. You can delete things from a table. And the question mark here is to show you that you can leave some parameters open. So what happens here, you say age is whatever to be specified later, right? And then you set that integer to 65, right? And then that's going to execute where age equals 65. And then you change it to 150, and then that's going to say where age is 150, and so on and so on and so on. Okay. All right. This is another example. So that was Java. This is how it looks like in Python, right? Just so you get a feeling of what it looks like. This is what it looks like in PHP. And this is now what I told you about. In HTML, these are these tags. That's the beginning of the table. That's the end of the table. TR is the beginning of a row. This is the end of a row. TD is the beginning of a cell, and /TD the end of a cell. This is actually generating an HTML visual of a table, just iterating on the interface to PostgreSQL, right? You read the results of the table and generate the HTML visual that you will see in your browser on the fly that you can do with PHP. It's a different language, that's why it looks different from Java, right? But it's the same idea. Okay. I think I'm going to stop here, right? For whom does that make sense? Right? That's pretty advanced. This is really for people who actually build websites and they use PostgreSQL in the background, and then they have a lot of computer programs that build the SQL queries on the fly, get back the tables, and generate HTML pages for display to the user. Think of, I don't know, Digitech Galaxus when you connect to other things, or Amazon or whatever. The pages that you see, they are all generated dynamically. They didn't exist before you actually went there. And they were generating dynamically after connecting like that to a database that can be SQL or something else. So what I hope is that with what I explained to you today, I demystified the whole thing. Now I hope you have a better understanding of what's actually going on when you type an address in your browser, all the machinery in the background that happens that you might not have known before, right? But now you probably have a better feeling of what's going on, right? Between typing the address and seeing the results in your browser. Who feels like it's demystified a little bit, that they know a bit more? Okay, very good. So let me check. That you followed. Next time you can get to ask all the questions you want, you know, and let me find again, it's right here. So you can get to ask the questions that you want on the topic. You'll have exercises on the database design theory. Some of them graded as announced. And next week, I'll continue on this ecosystem. I'll talk to you about transactions in the sense of what happens if multiple people try to modify the database at the same time. This is what I'm going to explain next time. Let me check. So this is how I know if I slow down, I accelerate. Okay, that's good. So I still have a majority above 80%. Don't hesitate if you are less than half or something, interact with the TA team, ask questions, but above all, do the exercises. Try out the exercises, especially the database design theory. There's nothing better than actually trying examples. If you try examples, then you start mechanically processing them, and then that will make things clearer. All right, so thank you very much, everybody, for being here with us. Enjoy your meal at the Mensa and the exercise session. See you next week. Thank you.